problem like this, where there is a function given, but there is another variable introduced into the function. In this case, a k. So it's a function in x, but they're saying, well, we know this is a function in x, but there's a term there at the end that we're not sure of at the moment. It's a k. It's an unknown at this stage. But they ask you what values of k would give this function 2 x-intercepts. So once again, we can have 2 x-intercepts or 1 x-intercept or 1 x-touching or no x-intercepts. And they will change depending on what number is on the end there. And so what numbers could be on the end that would give this function 2 x-intercepts? That is what the question's asking. And just so you know, this is a very common type of question you'll see in assessment tasks or in exams, where they give you a function and they say, well, considering this function, what values of k would give 2 x-intercepts, or 1, or none, or whatever it is. In this case, they're asking for 2 x-intercepts. But we continue to use our knowledge of the discriminant. The discriminant equals b squared minus 4ac. So in this case, what is it? It's b squared, it's negative 2 squared minus 4 times 5 times k. So that equals 4 minus 20k. But we know something about the discriminant if there are 2 x-intercepts. What is that? What do we know about the discriminant if there are 2 x-intercepts?
Positive.
The discriminant is going to be positive. So we're going to say, what values of k will make this 4 minus 20k greater than 0? So what values of k would make that a true statement? So now we solve this inequality. Negative 20k is greater than negative 4, taking away 4 from both sides. Now get rid of the negative 20. Divide both sides by negative 20. What do I do to the inequality sign?
Flip it.
I flip it. Why?
Because you
Negative.
Yeah, I'm dividing or multiplying by a negative number. In this case, I'm dividing. So I flip it. Negative 4 over negative 20 means k is less than 1/5. So in this example, any value of k that is less than 1/5 will give this function 2 x-intercepts. And conversely, any value of k that is more than 1/5 would give it no x-intercepts. Okay, and so we could have so k equal to 0, and they'll have 2 x-intercepts. Or k equal to negative 1, or negative 5, or negative 10, we'll have 2 x-intercepts. If k was 3, positive 3, it would have no x-intercepts. Okay, and so as we work through the questions of the book, we'll have some questions like this, where you'll have another pronumeral introduced in different places. It could be in here, it could be in here. But again, we just use the same information. Use our discriminant, and then once we have an expression for the discriminant, we then introduce what we need to know. In this case, 2 x-intercepts, so it must be greater than 0.
Do you put it then back into the original equation?
No, so it depends what the question asks. So in this case, it's what values of k is the question, and so I'm just answering with an answer that says k is less than 1/5.